Okay, now let's go on to question 10. Figure 10.1 shows two lamps X and Y operating at normal brightness. So if they're operating at normal brightness, that means that most probably they will be operating at 12 volts. Okay, otherwise they're not operating at normal brightness. They ask you to calculate the current flowing through each bulb. Okay, calculate the current flowing through each bulb. If you look at both bulbs, they are actually having the same power rating. They have the same voltage. So what we can do is we can actually just use a simple formula, P equals to IV. Okay, because I want to find the current. Power I know is 24 watts as indicated. Current is whatever I want to find. And the voltage I know is 12. So the current across each of them is actually 24 over 12. I'm going to get 2.0 ampere. So the current in X and the current in Y are both the same because they're operating at normal brightness. It'll be 2.0 ampere. Okay, 2.0 ampere. 2.0 ampere. Next one, calculate the current flowing through resistor R. So if I know the current coming here is 2.0 ampere, the current coming here is 2.0 ampere. Now if you think about it, what will be the current here? So current flows out from the source, goes through resistors R. When reach here, it will split. And 2.0 here, 2.0 here means that the current flowing through R before it splits to X and Y will be the sum of them. So the current across R with the current across the X plus the current across the Y. So this will mean is 2 plus 2, so it's 4.0 ampere. 4.0 ampere. Now calculate the resistance of R. Right? Calculate the resistance of R. Now how to calculate the resistance of R? First thing, to find the resistance, I need current. So I have current already. The next thing I need is the voltage. Now this whole thing is 20 volts. I know that the voltage, the potential difference, the voltage across here, oh, so fat. Okay, let me erase this out, this is too fat already. Okay, the voltage across here is 12 volts. So I know that the total voltage first was equals to the voltage across R plus the voltage across X or Y. So why is it so? It's because these two are connected in parallel. So 12 volts here, 12 volts here. The energy used up for the thing will be 12 joules per charge. So I know it's 20 volts. I need to find the voltage across R. The voltage across X and Y already mentioned was 12. So the voltage across R is actually 20 minus 12. Okay, so this will be 8 volts. Now that's the voltage across R. But I need to find the resistance. So the voltage across R is equals to current across R multiplied by the resistance of R. So 8 equals to 4.0 times the resistance of R. So resistance of R equals to 8 over 4. What I'm going to get is 2.0 ohm. 2.0 ohm. Now, they ask calculate the power dissipated by resistor R. So find power equals to IV. I know the current is 4. I know the voltage is 8. So it will be 32 watts. So the power is 32 watts. Find the effective resistance of the two lamps connected in parallel. So we know that the two lamps, okay, we have the watts, we have the volts. Let's find the resistance. Okay, or the other way is let's use V equals to IR. V of X times I of X equals to R of X. So the V across X I know is 12. The current across X I know is 2. Then we can find the resistance of X. So Rx, it will be equals to 6 ohm. Now, the effective resistance of two lamps connected in parallel will look something like this. 6 ohm. This also 6 ohm because both of them have the same resistance. They have same voltage, same watts. The resistance will be the same. So to find the resistance of X and Y, so R of X and Y is equals to 1 over 6 plus 1 over 6. Bracket inverse because they're in parallel. So the answer I'll get is 3 ohms. Right? So resistance 3.0 ohm. Now last part. Part F, it says a copper wire is now connected across junctions C and D. Then explain how the brightness of X and Y will change. So now imagine at this point here, let me erase the blue part. I'm gonna use a different color here. Let's use orange. Okay, let's make it thicker. Okay, so from C connected to D. Now, this is just a copper wire. So take it as this one has no resistance. Okay, no resistance. Now, how will current flow? Let's use a different color to show how current is flowing. So current flows like this, goes through R. Now, when it reaches this point, there are three different paths it can go. It can either go this way, it can continue to go down, and then go this way, and then go this way. So there are three paths it can go. So one, two, three. Okay, so maybe if I were to redraw this for you, actually it looks something like this. Okay, this whole thing can actually be connected to draw on something like this. Light bulb, like that, light bulb. Okay, so actually you realize this wire here is going to cause what we call a short circuit. Okay, so I'm going to fill up now the answer. Okay, so based on the drawing, we know that it will cause a short circuit. So with the copper wire connected, it will short circuit C and D. It will short circuit the current from C to D. Hence, no current will flow through lamp X and Y, so they will not light up. Okay, they will not light up. So that's for part F. So this is the end for your assignment.